The flick of a switch. That's how easy it is to get electricity, right? If you're one of the lucky ones, then yes. But in 2017, there are still over 1 billion people who do not have access to electricity. In this video, we will discuss how electricity is generated and transferred to our homes, for those of us fortunate enough to have it. There are a variety of ways in which electricity is generated or made. How many can you think of? Some are shown in this image. Solar panels, wind turbines, biomass, hydroelectric, nuclear, and fossil fuels. And then there is also geothermal energy, tidal power, and wave power as well. Except for burning fossil fuels and nuclear, the rest are renewable sources of energy. Currently, about 80% of the world's energy comes from fossil fuels. First, we're going to have a look at burning fossil fuels in power stations to generate energy. And then we'll look at the national grid, which is relevant for both non-renewable and renewable energies. So, fossil fuels in power stations. Most power stations use coal as an energy source, and they work in the following way. 1. Coal is burned in a power station. The heat produced as the coal burns is used to heat water. The water boils and turns into steam. 2. This steam is used to turn the blades of a turbine. A turbine looks like a fan or a wind turbine. The turbine turns a generator. Inside, wires turn within magnets to generate electricity. So that was a fossil fuel power station. These next steps are for energy generated from any source, whether it's fossil fuels or renewable, like wind-powered substations or biomass-fueled. 4. The electricity, whether renewable or not, is passed through transformers and wires within the national grid that carries it to our
How does electricity reach our homes? It all starts from the power station, which gives a voltage of 20 kilovolts. But, to transmit this voltage over longer distances, it is stepped up with the help of step-up transformer. The transmission lines carry this voltage to the substations or distribution stations, where the voltage gets transformed from 440 kilovolts to 11 kilovolts, which is safer for distribution. Again, the voltage gets decreased 1 or 2 steps, with another step-down transformer, before reaching our homes. So, basically, transformers step up or down the voltage, before making its final way to the destination. But, how it's done? The transformer usually consists of an iron core. The sides of the iron core are wrapped up with a coil, termed as primary winding and secondary winding. While for a step-down transformer, the primary winding has more turns than the secondary winding. Now, when a high AC voltage is given at the input, it excites the primary winding. After this excitation, alternating current circulates the winding and creates an alternating magnetic flux, which passes through the magnetic iron core. This alternating magnetic flux induces a voltage in the secondary winding. Since the number of turns in the secondary winding is less, the induced voltage will be low. So, without making an electrical contact, the voltage in the primary winding is transferred to the secondary winding. Simultaneously, for a step-up transformer, number of winding turns in the primary winding is less, compared to the secondary winding. In our daily lives, transformers are everywhere, from the utility provider lines to the mobile phone chargers. In this case, it steps down in a small amount, nothing but incoming voltage reduces to 5 voltages for charging your mobile phones.
electricity leaves the power station, it passes through a step-up transformer. A step-up transformer increases the voltage and reduces the current. Reducing the current makes the transfer of electricity more efficient, as less energy is lost as heat. Before the electricity gets to our homes, the voltage needs to be reduced back down to a safe level. The electricity therefore passes through a step-down transformer. To learn how transformers work, watch this video. So, now you know how electricity is generated and sent to our homes. It's not quite as simple as flicking a switch. Quite a lot of infrastructure is needed.